In question 71, we're given the following graph, and we're told that it represents the effect of changing or increasing the concentration of substrate on an enzyme-controlled reaction where the other variables are kept constant. Okay, given that, we're asked to work out which of the following three options could potentially be the y-axis of this graph. Now, before we look at the three options, let's have a look at our graph. We can see that increasing the concentration from 10 to 20 arbitrary units leaves our y-axis completely unchanged. There is a flat line. Okay, bearing that in mind, which of the following three could be the y-axis? Firstly, the rate of substrate loss. Secondly, the rate of enzyme-substrate complex formation. And thirdly, the rate of product formed per enzyme molecule. Okay, in order to gauge this question and where it's coming from, let's quickly remind ourselves of what's happening in an enzyme-controlled process. We have our enzyme plus our substrate, which forms an enzyme-substrate complex, and therefore forms, and then subsequently forms enzymes plus products. Okay. If you were to have a look at a graph of enzyme activity versus substrate concentration, under normal circumstances, this is the typical graph we're familiar with, we have an increase in enzyme activity as substrate concentration increases. However, after a given saturation point, this graph tends to flatline, and it's this flatlining that's being gauged in this question. We should be familiar with the idea that after a certain concentration of substrate, provided the enzyme concentration is kept constant, as it is in this experiment, eventually all of the enzyme active sites will be occupied, and increasing the concentration of substrate will have no impact on the rate of reaction. Bearing that in mind, let's have a look at the first of our three potential y-axes. So the rate of substrate loss. Well, when are substrates lost? Having a look here, we can see that substrate loss is a byword for the process of enzyme plus substrate going to enzyme-substrate complexes. In this process, substrates are technically lost and then go on to form the products. So, could the rate of substrate loss, i.e. the rate of enzyme-substrate complex formation, be constant? Well, we know from our graph that after the saturation point, this could well happen. Increasing the concentration of substrate could have no impact on the rate of formation of complexes and therefore the rate of substrate loss. So we can say for 1, and indeed for 2, which is saying the exact same thing, these could both potentially be our y-axis, provided we are after the saturation point. Moving on to number 3, the rate of product formed per enzyme molecule. Could this also be the y-axis? Well, again, we're focusing on a specific part of our equation here, the formation of products from our enzyme-substrate complexes. Now we know that when there is a lower substrate concentration, i.e. the enzyme, or rather the substrates are the limiting factor, increasing the concentration of substrates will increase the activity of an individual enzyme. However, after the substrate point, increasing the concentration of substrate won't improve the efficiency or the number of products formed by an individual enzyme. So again, during this plateau period of our graph, we would likely see a plateau in the rate of product formed per enzyme molecule. So these are all potential answers, so we can say our answer is therefore H, but only in the circumstance where substrate concentration no longer becomes our limiting factor, but rather enzyme active site availability becomes the limiting factor.